One of the often overlooked features of ActionScript is the robust nature of its sound APIs. In this lesson, we'll see how to set up a sound object for MP3 playback. So in Flash Builder, we do a number of imports here, including flash.media.sound, which is the primary sound object in ActionScript, and it's supported by things like flash.media.sound channel, flash.media.sound mixer, and sound transform. We load in the actual MP3 file through flash.net.url request and can monitor the bytes being processed through flash.utils.bytearray. So let's look at some of the variables that we've created for this class. So here we're creating a private constant of sound_file, which is a string pointing to music.mp3, which is a file on our local system here. We're also going to create a private variable called sound, which is mapped to a sound object. S_transform mapped to sound transform. S_channel, which is a sound channel object. And then we have a variable called ID3, which is a Boolean. In this, we'll check to see if we've received ID3 information from the MP3 file yet. For those who are unfamiliar, ID3 has a lot of metadata around who the artist, title, album, year, and so forth in an MP3 file, so we can read that information and display it to the user. We'll also have a look at the sound bytes, and this is going to come to us in the form of a byte array. So in our constructor function, we're going to initiate our stream through initStream. And within that function, we'll set our S_transform object to a new sound transform, passing in 1 and 0. And we can see here that 1 is equal to volume. Volume is going to be either from 0 to 1. So if you wanted to be at 50% volume, you'd pass in 0.5. And panning, very similar, except it goes from -1 to 1, with 0 being the actual neutral panning. So equalized panning between left and right. We then set sound equal to a new sound object. And for this, we pass in a new URL request, which points to our actual sound file. Sound file, of course, is our constant, being defined up here as music.mp3. We then added an event listener to our sound object of type event.id3. And when that happens, we invoke id3 loaded. This will let us know that all the id3 information for this sound file has been loaded, and we can then read it and display it to the user. To actually play the object, we're going to play it through a sound channel. So we say S_channel equals sound.play, and then pass in a number of different arguments here. These arguments include the start time. So this is an offset starting at 0. We're going to play from the beginning, so we just pass in 0. We can say how many loops that we want to play the sound for, so we could play this any number of times. We're going to say 0, and in this case it's not going to loop at all. It'll just play the file once, and that'll be it. And then we pass in our sound transform, and we just pass in S_transform for that, as we've already established it above. When our ID3 loaded fires off, once the ID3 information is loaded in our sound file, we can then look and see, has the ID3 information been fired off yet? If not, then we begin tracing things out, such as the name of the song that we're playing, the album it's from, artist and year, all based off the sound.id3 information. We then set ID3 equal to true so that we don't actually spit this out multiple times. And then we can set our sound bytes to a new byte array object. And we can set an event listener of type event.enterFrame to monitor mixer every frame. Scrolling down a bit here, we can see that every frame we call monitor mixer, we're going to look within our sound mixer, and we're going to invoke compute spectrum, with which we'll pass in sound bytes. So this will spit out the actual bytes that are being processed at any of that time to our sound bytes byte array object. We can then trace out sound bytes.bytes available to let us know how many bytes are actually available at any given time. This is useful if you want to do things like display the sound byte information visually through some sort of spectrum analysis. So let's have a look at how this works. We'll run debug here. And we'll stop it. And we can see that it's spitting out here 2048, and this is being handled by the monitor mixer function. So every frame it's going to trace out those bytes that are available. And if we go up to the top, we'll be able to see this little bit here, which is the ID3 information being passed along. So we can see that the name of the file that's being played, the name of the track, what album it's being played from, the artist, and the date of the album. And there's actually a lot more stuff you can do with sound and audio in ActionScript 3. You can use all of the different things that we've touched upon here, such as channel, mixer, and transform, to explore these things individually.